If we're ready to go in the room, the next talk is from Igor Khokhriakov, who's my colleague in the scientific computing group for photon science here at DAISY. I think he needs a moment to get connected. Seems to be working. Yeah. And he's going to talk to us about how to write and read HDF5 files from pure Java.
Yeah, welcome everyone. I'm Igor Khokhriakov, and today I will present something that is actually not my work, but someone else's. So I will be doing some advocating, and as I believe it's related to Java, that will be more like being a devil's advocate. But what I want to present today is this JHDF library, which I found recently, maybe half a year ago or something like that, on a GitHub. And apparently it helped us to solve some of the, let's say, small maintenance issues we had with our project. But first, I was thinking, when I was thinking how to present someone else's library, obviously the like straightforward thing would be to do some kind of hello world example. But I believe nowadays it's dumb and stupid to do a hello world. So I was thinking what would be the catchy thing to implement. And since we are nowadays talking a lot about LLMs, I decided to go with some project which I believe to those of you who are related to beamlines will make your heart beat faster. So the idea is that imagine you have an ELN records, electronic laboratory notebook records, where you can just type an arbitrary text or whatever sentences and describe your experiment. So this is obviously a simulated thing, just aggregated number of imaginary ELN records which describe some experiment. And what we can do with ELN, large language models, is to actually extract structured data out of it and store it in HDF5. So the storage part is implemented in that library I was mentioning, but first let me just run a few examples and show you the magic. So let's try. I mean, I'm running a Olamas model locally on the small laptop. It doesn't even have a GPU, so it's pure CPU mode. So it's a little bit small to maybe do very sophisticated things, but we'll see. And it's kind of unpredictable. So it's from time to time, you might have some errors there, but nevertheless, it's wrote something, and we can explore it using, say, H5 dump. That was number 1, H5. So it extracted some data, like experiment, what's that? Like the title of the experiment, the date I store in milliseconds, some instrument source type, some NAs, some arrays of data. So if we look into the source, it was like angles. Here we have, oops, sorry, where is it? I lost it. Yeah, so polar angle, 10, 11, 12, 13, and some detector readings. So I think you got the point, right? And now I will just quickly look through the code, so how it's implemented. I hope it's interesting. So first of all, as I mentioned, I created in the end some structured data, which is native Java pure object. And I borrowed the structure from the Nexus definition. So the actual Nexus definition is located here. And it basically says that we have some kind of entry, which is like a root thing. And then we have some instrument, source, crystal, and so on and so forth. So out of that, I have this structure, Java structure. And the whole magic happens here. So first I initiate my client to the LLM, which, as I said, runs on this laptop. I use relatively small model. I think it's like 32K entry context points. And there is some other model-specific settings. And then the library I'm using to interact with LLM actually allows me to create so-called AI service. So this is some augmentation to LLM. And in this particular case, it's very simple. It's basically says, so this is a supportive message to the LLM. And it says extract experiment info and return in JSON what is Java type of such a structure. And it provides a user message. So this is kind of faking user prompt. And talking Java, it's basically take a string ELN records, which might come obviously from arbitrary source like Kafka, data file, whatever, and return the structure. And then I create an HDF5 writer, which we will take a glance in a second. And then it's basically like this. So read input from a file, extract, and then write it into HDF5. And at this point, we are already at HDF5 library, JHDF library, to be precise. And again, writing is straightforward. So we create a resource, which is a writable HDF file, and then we basically put datasets. So we can put scalar, we can put arrays, and all the typical tasks we can achieve. There are a few caveats, and I will, so first of all, it's, as you can see, it's not really a hierarchy here, right? So I cheated a little bit and flattened like the fields names. This is because if we write something like this, unfortunately, library doesn't recognize it. And I will show another project of mine, which is actually runs on a beamline and collects the data from our sources and puts them into HDF5. And I will show how to work around that. And yeah, another thing is that it's relatively difficult to maintain. So it supports like mostly primitive types. And if you have some sophisticated stuff like Java collections, you have to do things like this or just write in a different way. But anyway, I think that's already good introduction. And let me then switch to another project of mine, which demonstrates how to work around those things in JHDF5. Just a little bit of the context and the history. So this is a metadata acquisition and management system I implemented like a decade ago, roughly, for our beamlines at here, DAISY. It's PO5 and PO7. This is very high level overview. Basically, it collects all the data in the end, puts into HDF5 file, following like the Nexus format standardization. And those HDF5 files are basically our artifacts we then use for like post-processing and providing it to the users. And the tricky part of the project. So this is a component that is called data format server. This component is responsible for writing data into HDF5. The tricky part is that our beamline scientists can change the structure of the HDF5 file somewhat on fly. So before the experiment, they have a GUI where they say, okay, I want, let's say, this hardware attribute, that hardware attribute, and some extra metadata there. So we don't know in advance the structure we will then write on the HDF5 file. But basically, this is very simple component. So there is a data flow in, which is basically like a plane mapping from like upstream hardware data or some other stuff, but mostly it's a hardware to some HDF5 paths. And these HDF5 passes, they are defined in XML following Nexus format definitions wherever possible. And the first implementation was based on libpni.io, which basically invokes GNI approach, so Java native interface. So libpni.io was a C++ library and still is C++ library on top of HDF5, which provides us API to create Nexus files. And if you have an expertise in any of like Java or C++, this code will immediately make your eyes bleeding because it's kind of aggregates evils from both worlds. So this GNI thingy in C++, you have to use row pointers for data management, and passing data around is a nightmare. I mean, from Java to C++, unless it's a pointer, and so on and so forth. And also, basically, it requires deep knowledge of GNI and upstream C++ libraries. Very long dependency supply chain because you have your Java artifact, then you have your GNI artifact, C++ library, and HDF5 library, and something and other things. I'm not talking about non-trivial deployment because both things are unnatural for C++ or Java. And finally, specifically for libpni.io, to my taste, it abuses C++ metaprogramming. So this was not a big deal. I mean, this project is in production, serving actual users at the beamline for almost 15 years now. Recently, the only headache was to migrate from when our experiment control group updated the operating system, because then you have to recompile all the native stuff. Eventually, as I mentioned, I found this library and rewrote the whole component in pure Java. And as I mentioned, the main cave it was to deal with the limitations of the library. So basically writing in a, let's say, complex nested structures. And for that, it's easy to work around. So basically what we are doing with an LXDL parser, an LXDL, sorry, it's a Nexus definition language. We just parse it. So at config time, so we are when our beamline scientists configure the experiment, so they essentially creating this XDL file from scratch, and then before they run in the experiment, there are routines that create those files and pass it here. And here we parse it and create basically a mapping, like a plane mapping from HDF5 path to a writable node. So this way you can basically write to any nested node. And another thing, yeah, you basically need to deal a lot with writing arrays, and that's basically it. So this works pretty well. So for instance, I have a integration test. Sorry, where is it? Yeah, here. Which basically writes 1 million doubles. And if we run it, it works like for 500 milliseconds. So this is very fast. This eliminates basically any need for dealing with native libraries, and we use pure native Java experience. The library itself, Java HDF, is best for plain flat structure, so they don't need to do all that hassle with dealing with the nested objects. It's obviously trivial dependency supply chain, and you just put a dependency into Maven, Gradle, or whatever you're using for the dependency management. It's trivial deployment. It's pure Java, so you just now need to copy paste jar file around and it runs, or even just wrap it into the Docker. And well, there are room for improvement in this library. So some features ain't implemented. As I said, there might be a way to kind of provide a pass instead of just a node when you write something. And there are some other limitations. And to my taste, it exposes HD5 internals too much into the API. So I would look into some, maybe utilizing reactive API, reactive streams API from Java to manage those. And some closing thoughts. So with that pure Java implementation, we completely eliminated any headache, as I said already. And results shows that this minimalistic approach fits the best our needs. And minimalistic, I mean that we kind of separated every component following the single responsibility concern. And there is also in Java 21st, they introduced so-called foreign functions. So this is Java Enhancement Proposal 442. And that basically should significantly improve experience with calling native function and of heap memory management. So that might be worth checking out. And even for HDF minus Java library, which is using J9 under the hood. And as I believe not many of you actually using Java, sorry, the main takeaways from my talk would be, I was trying to do them as generic as possible. So the first thing, mixing technology in one project is possible, and we have a very good case demonstrating that, but not desirable. And another takeaway would be, before jumping into implementation of something, maybe explore a little bit what's already on the market, and possibly someone already fixed your problem, and as it was with JHDF. I would like to make some acknowledgements. I don't know if you know these guys personally, but Eugen Wintersberger is original developer of libpni.io, Jan Katansky, who eventually took over. So they supported this library, and it worked well for us, even though now we removed it. There was very little headache with it. And with that, basically, thank you. And any questions?
Okay, thanks a lot. Any questions or comments? One at the back.
Thank you for your talk. And I have a question. So you showed two examples, and I have a question concerning the first one. So you showed us how to write, but I mean, is it possible to read from HDF5 using LM, for example?
Well, that's a great question, actually. I forgot to mention. If we go back to the application, well, LLMs usually support so-called agents. And this is kind of piece of functionality which you inject into LLM. And with that, you can even call functions from your code. Unfortunately, Olama, which I'm using, it's kind of local model, doesn't support that. And in this library, it's called tooling. But we could implement such an agent which may access HD5 directly. And the use case would be, for instance, as I imagine, it's where you have a bunch of HD5 files with experiments, and then you can type something like please give me all the experiments with, I don't know, such and such parameters. And that's basically a semantic aware search, or this. So this opens a window for a large variety of applications, so-called RAG applications. So it's a retrieval augmented generation. Basically what that means, user prompts something, AI goes to the data source, extracts relevant data, creates a context, and then performs whatever operation within that context. So yeah, the answer would be yes, it's possible. There is even a great, as I see there, great possibilities for that, but unfortunately this thing doesn't support it. So I probably forgot to mention.
Okay, thank you.
Question.
Any other questions or comments?
Thank you very much. I was wondering, so the example that you showed is like to create the metadata of some H5 data before the starting collection, or for example, it looks to me like a logbook. If people put some pictures or images in the logbook, is it also gonna take it to the H5 or?
Yeah, this is just a very quick implementation I came up just to demonstrate like the possibilities. And yes, the idea is that this particular example extracts metadata from logbook entries, but of course we can add anything we want to that. So I would expect, so let's say, if we talk about my project, which I showed, I would see this as another service which will provide data flow into the data format server, if that makes any sense.
Yes, thank you.
By experiment standards, this is already beautifully distilled and formatted and structured log, right? So
yeah, I mean, this whole thing implies that you have an infrastructure that will provide you the data in the first place.
But it would be interesting to see what happens if you throw in like the logs from one of our experiments here, right? And see what happens.
Sure. I mean, I find this like a great opportunity for some grants. So if anyone interested, maybe collaborate on that. Just come and ask.
Any further questions or comments? I don't see anything online either. So let's thank Igor once again.